This video will be talking about calculus with tangent, cotangent, secant, and cosecant. Okay, so though, if you want to take a little moment to write down these derivatives and integrals, please do so. Just pause the video and just write them down. So what we're going to be doing, we're going to do some examples, first with derivatives and then with integration. So just the derivative of tangent is going to be secant squared of x. The derivative of cotangent is negative cosecant squared of x. The derivative of secant is secant x tangent x. The derivative of cosecant is negative cosecant x cotangent x. And if you see here, if I were to take this left-hand side and attach an integral to it, you will see that you will get the other side. Some of them have a negative because you have a negative on their derivatives. So yeah, that's basically what you have for the derivatives and the integration. So now let's do some problems. Just a couple. So here, let's take the derivative. So differentiate. Okay. So let's go ahead and take f of x is equal to x cotangent of x. Okay, so what will be the derivative of this thing? Okay, well, let's go ahead and take the derivative of this, and you can see that you have two different functions being multiplied together, so you have to use the product rule. So the product rule in this case would be the derivative of the first, which is just going to be 1, leave the second one by itself, which is going to be cotangent of x, plus, now we're going to take the derivative of cotangent. And if we look back up, the derivative of cotangent is negative cosecant squared x. It's going to be negative cosecant, cosecant squared x times and then we leave the x by itself. Okay, so if we were to clean this up, we would have cotangent of x minus x cosecant squared of x. So that would be the derivative of this thing. Okay. Now let's do another problem. So let's say we want to do f of x is equal to cosecant to the 4th power square root of x in the inside. Okay. So now, whenever you have something like this, you notice that you have something in the inside, and then you have this 4th power. So how do you do something like this? What would you even do first? Do we start with the cosecant first? Do we start with the 4, or do we start with the square root? Well, one thing that I like to do is I like to rewrite this a little bit. So I like to write it like this. So we were going to write cosecant of square root of x, and then we're going to bring the 4 outside, because this is basically what this is. You're taking the 4th power of this cosecant function. Okay, so now what you want to do is let's go ahead and take the derivative of this. Okay, so this thing, the derivative, is going to be equal to, so let's bring the 4 to the front and subtract by 1. So I'm going to have 4 subtracted by 1 is going to be 3. Okay, the inside is going to stay the same. So you're going to have cosecant of square root of x times the derivative of the inside function, which is going to be cosecant square root of x. I'm going to write it like this to know that we're going to take the derivative of that. So this is going to be equal to 4 cosecant square root of x to the 3rd power times the derivative of cosecant. Well, if you go back up, the derivative of cosecant is going to be negative cosecant x cotangent x. So this thing is going to be negative cosecant x cotangent x. Now notice what is inside of the cosecant and the cotangent. Inside of the cosecant and cotangent is going to be whatever's in the inside of the cosecant, okay, of the original cosecant. In this case, it's going to be square root of x. Okay, so this is true. So it would have been x and x if there was an x here. But in this case, there's a square root of x. So we're going to write square root of x in there. Okay, and now finally, times the derivative of square root of x. Okay, so whatever the derivative of square root of x is going to be. Okay, so now let's go ahead and do this. So this is going to be equal to 4 cosecant of square root of x to the power of 3 times negative cosecant of square root of x cotangent of square root of x. The derivative of square root of x is just going to be 1/2 x to the negative 1/2. Okay, and at that point, this looks really, really messy, but let's go ahead and clean it up a little bit. So I'm going to go ahead and put the 1/2 and the 4. That's just going to give me 2. I'm going to have 2. Let me write this as cosecant cubed of square root of x. Then you have a negative. Let me bring that negative to the front. Then you have this cosecant square root of x, cotangent square root of x. Then you have this x to the negative 1/2, which I'm going to put to the bottom, x to the 1/2, and there's a 2 also on the bottom. Okay? Notice here that we can get rid of these 2's. Okay, so I'm going to have a negative. There's an x to the 1/2 on the bottom. Notice that these two are the same thing. So that's going to give me cosecant to the 4th power square root of x. And then you just have this cotangent. Oh, there should be a cotangent. Okay, cotangent of square root of x. Okay, really messy, a lot of stuff, but at least you'll have these formulas. So these formulas, you don't have to memorize them. Okay, you will actually have them. Okay. All right, now let's do a couple of integrals. Okay, so now let's integrate. Okay, so let's say, for example, what we have is the integral of secant of x squared of square root of x divided by square root of x dx. So let's say we have something that looked like that. Okay, so the first thing that I notice is that you have a secant squared. So if I go back up, what was the integral of secant squared? Well, that was just tangent, right? So you can imagine that there's going to be a tangent, but you don't have an x in there. You have a square root of x. So maybe let me go ahead and make it this way. So let's write it like this. So the integral of secant squared x to the 1/2 divided by x to the 1/2 dx. So we can write that like that. Okay. Let's go ahead and move it up a little bit more. The integral of secant squared x to the 1/2 times 1 over x to the 1/2. And you can see that this is actually true. Now you're probably wondering, why are you doing that? Okay, well, you're gonna see right now. Because if I let u equal the inside function, x to the 1/2, then the derivative of this is gonna be equal to 1/2 x to the negative 1/2 dx. I can move the 2 over, so you have 2 du is equal to x to the negative 1/2 dx. And what exactly is this thing? Well, this thing is just x to the negative 1/2. Okay, that's what that is equal to. Okay, so if you want to rewrite it like that, you can write it as integral of secant squared x to the 1/2. This is times x to the negative 1/2 dx, which is basically bringing it to the top. So now all we have to do is just, let's do this u substitution. So we have the integral of secant squared. The inside now is going to be this u. This guy is going to be this 2 du. So I can pull out the 2. Integral of secant squared u du. And then finally, the integral of secant squared u is just going to be equal to tangent of u plus c. And then u in this case was x to the 1/2. So it's going to be 2 tangent x to the 1/2 plus c. And obviously you can change that x to the 1/2 to a square root of x. Okay. All right. Now let's do one last problem. B. So let's say we want to do the integral of the square root of tangent of x, secant squared x dx. Okay. So the first thing that you want to notice is that you kind of have the derivative of tangent, which is just going to be secant squared. So it's good to make u be your tangent of x. So then your du is going to be the derivative of that, which is secant squared of x dx. And you don't need to divide anything over. So you're going to have the integral of the square root of the inside function, which is just u. And this whole thing is going to be absorbed by this du. Okay? So you're going to have the integral of u to the 1/2 du. Then just basic antiderivative Okay, and what I'm going to have, this is going to give me u to the 3 halves divided by 3 halves plus c, which gives me 2/3 u to the 3 halves plus c. Now u initially was tangent, so you're going to have 2/3 tangent of x to the 3 halves plus c. Okay, and that will be your answer.